Welcome to my 8th graders. Scaling three-dimensional figures is what we're going to work on today. This is the last chapter for our section, so you won't see me for a few days, but you will very soon see the products. We have a Google form and a review that you can do after this. Now, the surface areas, you guys have done great with those. Hopefully, you can call me if you have a question, or I know many of you FaceTime and discuss your problems. So, go ahead and work and do it that way if you need to. Now, the problem of the day was done well. Good job. Learn to make scale models of solid figures. Capacity is the main thing we're going to talk about today because we have been dealing with area, volume, and surface area. Now we deal with capacity, and you're going to see what that is. So, if we're scaling three-dimensional figures, we must remember there are 3 dimensions. If we scale them up, we are going to scale all 3 dimensions with the same way. Whether it is by a multiple of 2, a multiple of 3, a reduction of 1/2, they're going to be scaled up or scaled down by the same amount. Now, if you need to, you can pause and read this. Corresponding lengths of any 2 tubes are in proportion to each other. That's what we talked about, going up by the same amount or going down by the same amount. The multiple or the division of, all right? So each edge of the 2-foot cube is 2 times as long as each edge of the 1-foot cube. However, the capacity or volume is 2 to the 3rd power. It equals 8, and 1 to the 3rd power only equals 1. So its surface area is 4 times as large as the 1-foot cubes. So while we may scale up figures, their area and their volume change by much different amounts. Volume many times changes by a lot more because of the multiplication factor, and so does surface area. So be ready for that. Multiplying the linear dimensions of a solid by n creates n squared, as much surface area and n cubed as much volume. So if it grows by 1 or a multiple of 1, it's going to be 3 n to the 3rd larger. If it grows by a multiple of 1 for area or surface area, n to the squared. We'll talk about that. A 3-centimeter cube is built from small cubes, each 1 centimeter on an edge. Compare the following values, the edge lengths of the 2 cubes. So let's look at what we're seeing. The ratio of the corresponding edges. We have a 3-centimeter cube and a 1-centimeter cube. Okay? So the ratio is 3. It went up by a multiple of 3. The length of the edges of the larger cube is 3 times the length of the edges of the smaller cube. Since we went up by a multiple of 3, we're going to then check their surface areas. Okay? So, scaling model, we went up by 3. Let's see how it does the ratio of the corresponding areas. All right? So the 3-centimeter cube and the 1-centimeter cube. The 3-centimeter cube has a 54 centimeters squared, and the 1 centimeter has a 6 centimeters squared. That is by a ratio of 9. Did you notice that 3 squared is 9? Remember how it said n squared? So if the ratio goes up by 3, you put 3 in for n and you square that, you get 9. The surface area will go up by 9. We'll show you the next one. All right, the surface area of the large cube is 9 times that of the smaller cube. Now we're going to do the same thing. We have those cubes that are different. 3-centimeter cube and a 1. Their volumes, much different. The volume is 27. This is 1. Oh, 27 times larger. But remember how they said? 3 to the 3rd. Oh, it did go up by that. So before we do this one, scaling. Whoops. If it goes up by n, that's the number of multiplied times it goes up. If the scaling goes up by 2, the surface area goes up by 2 squared. That's 4. If it goes up by 2, the volume goes up by 2 to the third, and that's 8. They grow by much different rates, just as we saw with that. Now, a 2 centimeter cube as compared to a 1. The scaling is going to be a multiple of 2. So if we put 2, which was the scaling, into the end, 2 squared is 4. That's what we'll come up with. For the volume, if we put the 2 in there, 2 cubed is 8. That's what we'll come up with. And here's my proof. Alright, so 2, it was a multiple of 2. We do the surface area. Surface area for that, surface area for the 1 centimeter, 24 to 6. Hey, there's that 4 we talked about earlier. And with the volume, you're going to see 8. Okay. Now, a box. Go ahead and read that for just a second here. A box is the shape of a rectangular prism. The box is 4 feet tall, and its base has a length of 3 feet and the width of 2 feet. For a 6-inch tall model of the box, find the following. What is the scaling factor? So, 6-inch tall model. So the 4 feet went to 6 inches. We have to find what the scaling was. Alright? So they're going to take 6 inches and went to 4 feet. 6 went to 48. So the scaling factor was 8. And they simply changed the 4 feet to 48 inches. Or 1/8. So now we've got to do that same thing for volume and surface area. So remember this 1/8. We're going to use that. Okay? The scale factor of the model is 1/8. Now they want to talk about finding the following. What is the length and the width? Remember, the height went to 6 inches. So 3 feet would be 36. Well, we have to take that times 1/8. I'm going to reduce. That is 2, so that would be 4. That is 2, so that would be 1 and 18. I'm going to do that again. This is 2. This is 9. So would it be 4.5 was the scaling measure? Let's see if we're right. All right. 3 feet would be 36 over 8. It is 4.5. They took 36 times 1/8, or 36 divided by 8. And they got the answer. And they wanted to do it for the length, so they took 2, which was 24, and they divided it by 8, or multiplied by 1/8. They got 3 inches. Very well done. All right, and we go. Remember, stop, pause, look at any of these as long as you need. Now, the box is 8 feet tall, and its base has a length of 6 feet and a width of 4 feet. For a 6-inch tall model of the box, find the following. So, what is the scale factor of the model? So it went from 8 feet tall, and it's going to be 6 inches tall. So we need to turn 8 feet into inches. Well, 12 times 8 would be 96. And that's 6 inches. Okay, they're probably going to put 6 over 96. And then I would reduce. That becomes 3. This becomes 4 and 8. Oh, that goes nicely. That becomes 1. And that becomes 1 and 16. Our scaling factor is 1/16. So we're going to multiply by 1/16. We just reduced down and got our simple ratio here. They're going to show you the same thing. Convert and simplify. 6 inches equals 8 feet. Well, we're going to convert. 6 equals 96. They reduce by 6 and get 1 over 16. So the scale factor is 1/16. Remember I said ratio? Now, they want to know the length and the width. So the length is 6 feet. We may want to change that into inches. So 6 times 12 is 72. 72 times 1/8. I'm going to reduce. That's 9. That's 1. Oh. It's going to be 9 inches is my Bet. Do you see? Oh, we weren't supposed to do 1/8. We were supposed to do 1/16. My apologies. So this one then becomes 2, 9/2, or 4.5. There's my estimate for what the answer is. Let's see if I was right or wrong. All right, they do get 4.5. For the other one, we see 4 feet is 48 inches. We multiply by 16. I know that I can divide this one by 16 and get 3. That one's 1. I bet 3 is going to be our answer. Okay, let's go ahead and check and see if I did the work correctly. And there you go. Sorry you guys can't ask questions. This one does seem to be more difficult usually for students. Please don't hesitate to ask, and we'll do our very best to make sure you get everything you need. It takes 30 seconds for a pump to fill a cube containing container whose edges are 1 feet. How long does it take for the pump to fill a cubic container whose edges are 2 feet? Oh, we went from 1 to 2. The scaling factor was times 2. Filling a cube with liquid, that's volume. So we're going to need to do 2 cubed. It will take 8 times as long to fill the 2 by 2. So if we do 8 times 30 seconds, that will give us 240 seconds, which is 4 minutes. Or you can think this is a half a minute. Every 2 is going to be 1 minute, and that gets us to 4 minutes. Let's see how they handle it. All right, 2 feet times 2 feet times 2 feet, there's your 8. All right, set up a proportion and solve. 30 seconds for 1 foot, x over 8. Oh, they did the change, but watch when we cross multiply. 8 times 30 equals x. Well, 8 times 30, x equals 240 seconds. Or 4 minutes. You can set up the proportion. That works great. Or you can logic it out. I'm open for either and all options. So 30 seconds to fill a 1 by 1. Now, 1 goes to 3. That was a times 3 scale factor. 3 squared, or cubed, since it's volume. That's 27. If you take 27 times 30, well, you're going to get a very large number. 27 times 30, but I know 13 minutes and 30 seconds will be my answer because I divided by 2 since every one was a half. That's 13, and then the 30 seconds. You can set up your ratio as they'll do. All right? Hopefully you're thinking and you can see the ratio that we want when we do the volume, 27. Oh, so 30 seconds for 1 volume, or 1 foot volume. Don't know how many seconds for 27. We do our cross multiply. 30 times 27 equals x. That gets us 810 seconds. 810 seconds is 13.5 minutes. Okay? We can see these factors and how they work. I hope you all have questions, or I hope you don't have questions, but if you do, you know how to reach me. Thank you and goodbye.